Shenhao, you can take it away.
Yeah. Okay, so good morning, everyone. Today, Wei and I will be sharing on these convolutional neural networks on the image style transfer. Basically, I will be talking about the core architecture of this network. And then later on, Wei will share more about the advanced concepts built on top of its model and also some of its extensions. So without further ado, let us see how each one of us can actually be Van Gogh or Picasso ourselves. Okay. So basically, when we are talking about the style of an image or style of a painting, normally we are talking about things like the color scheme used in the drawing and also the techniques used by the painter. So if you're familiar with Photoshop, maybe you have heard of, or at least you have used some techniques like applying an effect or apply a filter to a certain image. And then you can see from the example below, on the left is a normal image taken by the camera, and then in the middle is a very famous painting called Scream. And if you combine them two, later on you can see that the photograph on the left actually has the effect, the color scheme, and also the drawing techniques showing by the Scream painting. Yeah, so basically we can see based on this example here, we can see there's a content image, which is the leftmost one. You want to show what you want to show in your final result. And in the middle, there's actually this thing called the style image, the techniques you want to apply to your final drawing. And also we have this, the rightmost image, maybe we can call it your own drawing. So the basic idea of the model is we feed all the three images into a pre-trained neural networks. And in our case, we're using VGG in this example. And we initialize our drawing with some random noise. And then we update the drawing image based on certain rules. The first one, for its style, we want to see how close it is to our style image. But then for the content, we want to make our drawing more close to our content image. And we want to combine these two criteria together and then apply changes to our drawing image. The overall architecture of the model, you can see there are, in general, 3 columns you can follow. The leftmost one is our style transfer. In the middle one is how you update the drawing image. And the rightmost is the content. As you can see, there's a photograph here. So let's dig into some of the details regarding this model. The loss function. Okay. So basically, the main idea of the whole architecture is to compare regarding the content as well as the style. So basically, here we will define our own loss function. One part of the loss is actually comparing how close you are to the content, and the other part is how close you are to the style image. There are many ways you can do this. At least you can find 2 or 3 implementations online. The basic rationale is for your target image and your own drawing, we want to compare the mean square error, which is you compare the Euclidean distance for every pixel value 1 by 1 for these 2 images. Following this idea, like separated by this line, there are 2 basic implementations on how you can actually define your own loss function. The one used by the author of the paper is actually this column, this part here. You can see basically F, P, G, and A are all representing the matrix after activation for a certain convolution layer, pixel by pixel. So these 2 equations is actually following the same logic here, compared to MSE. We will talk about this matrix G here because it's one of the core ideas for this neural network.
And then describe what functionally each of the matrices are trying to do.
Okay.
So you can give people an overview rather than talk technical first and then give the overview.
Okay. So basically, when we are comparing, or I can say when we are actually calculating the MSE for content as well as style, this matrix P and matrix A are your own drawing matrices, while matrix F and matrix G are the style and content matrix respectively. So these two equations are telling you how close our drawing is to the two target images for now. And the final equation, L total equals to alpha L content plus beta L style, is simply the concept we discussed, where we want a combination of both style and content update.
Sorry, can I ask a silly question? Why, since P and A both are referring to the drawing, right? Why?
Yeah, it's actually a very good question, because we are going to introduce this concept now. You see, in this example, this is another way of implementing this MSE concept. But this P here is the same as this P here, which is our drawing. But you see, when we are defining the style loss, we are changing the matrix P to another matrix G. This G is calculated by this equation, which is we are multiplying each matrix with its own Gram matrix or Gramian matrix. Simply is transpose. This is one of the most, I can say, most tricky part in the paper. They define this matrix from the original painting to be the style representation for each image.
Why this can be style?
I'm not sure whether you watch the video or not. In the video, Jeremy actually says something like this: when the paper first came along, nobody really knows why this works, but somehow it works. But if you think about the intuition behind this multiplication with its own transpose, then you can get some of the ideas. Okay, let's get into it. First, when you're multiplying a matrix with its transpose, you can see the first row multiply with the second column, or the second row multiply with the first column. These two will actually give you the same result, right? Because it's its own transpose. So the first row and the first column are actually the same. So your spatial or your location information is lost. And then if you consider each row or each column as a certain embedding of your alignment of color or the strength of the pixels in that row, then this multiplication can simply indicate how each alignment, how each of the color scheme interacts with each other. If you guys have experience with this concept called graph convolutional neural networks, then you will see there's a similar matrix multiplication inside. In the graph CNN, there's an important concept for this interaction called how the interaction of the nodes represented by the multiplication of matrix. So if we apply the same logic here, the multiplication of this matrix can somehow be represented, can be regarded as how the image looks like, how each row of pixels related to each other. If you think about it, maybe it can be viewed as the style of the image. I know it's a very tricky concept because it's very hard to visualize it purely based on the multiplication. But this is generally how this whole model works. I can see one of the core concepts of this neural network.
Do we have any visualizations of what the style matrix looks like? You can visualize the actual image of the itself, right? But what about the style matrix?
For now, I don't have the really image or example.
Yeah, it's okay. I'm asking our moderators. Maybe they can hunt something down.
Then shall I proceed?
Yeah.
Okay. Yeah. After you define your own loss function, the next thing is how you want to optimize your own images or your own drawing images. And in the paper, they are using this optimizer called LBFGS. Yeah, I'm keeping this slide simple because there are a whole bunch of mathematics behind this logic. But I can give you a brief introduction to this optimizer. Remember last section, we talked about this Hessian matrix. Basically, it's talking about the second order derivative for a certain function. And the main idea behind this Hessian matrix is it provides you information on where to move when you are actually trying to reduce your loss function. And for image processing, it's very easy to get a very, very huge Hessian matrix. And then build on top of a very huge Hessian matrix to find the direction is very, very difficult. And I think sometimes it's even impractical. That's why this concept of BFDS come along. Basically, it's trying to help you compute the direction without obtaining the actual Hessian matrix. And this concept of LBFGS is basically to truncate some of the steps in BFGS, so you don't have so much memory problem. They also mention very little on this concept. They just say, okay, this is a word we hate, but also we love. Empirically, this works best for image synthesis. So you can see some of the results. The top left one is the original photograph. And then you can see the 3 examples shown at the corner. For each of the image, you can see its original style image and how it looks when you actually combine this style together with original photograph. So the most famous one might be this Starry Night by Van Gogh. And then you can see you also have this star and then the tricky sky here.
That's interesting because didn't he say that in the video that you use any information about location by applying that? So it's quite interesting that the stars still end up in the sky.
That's right.
And not somewhere else. Like the intuition he gave about the star was kind of, yeah, you use any kind of information where things should be.
You lose the information about where.
So it shouldn't end up in the sky.
Yeah.
Yeah.
But I
It's
think
kind of counterintuitive.
yeah, I think how it's being transferred, and you guys can correct me if I'm wrong, is that the color aspects are still being localized, right? So you have some brightening at some point in the color transfer, and then that sort of hints that there should be some yellow there. So maybe it's not directly trying to create a star, but through the color, it's creating one anyways to colorize the object.
So is still the location kind of being transferred, because like in the bottom right image, B, so we can see in the screen there's this kind of ledge which is again being transferred there, but it's not being transferred anywhere else, even though the colors and the top are kind of similar. Are you getting what I'm saying?
Which ledge? You mean the ledge in the original screen?
Yeah.
You mean the hill?
This one or?
No, the yeah, I forgot what's it called. But basically, it's called the right next to the guy screaming. To the right.
Right, there's some road or
This part or this one?
Or this part, yeah.
Yeah, that's
Okay.
a fence,
Yeah.
right?
Yeah. Sorry, I couldn't remember the word. Yeah, so the colors of the fence are just on the.
Yeah, the fence looks like it got transferred to the river.
Yes.
You can see that the river seems like a little bit more fence-like. It has that artistic style from the fence, even though that's definitely in the original image just a reflection, right? Yeah.
Yeah.
That's a good observation.
Okay. And next is previously we have defined the parameters alpha and beta. So yeah, this is one simple further discussion provided by author, how the ratio of alpha and beta affects the final effect of your own drawing. It's quite intuitive, like you can see from the example here. Basically, it's whether you want to emphasize on the content or you want to emphasize on the style. And the final result will be how good you are preserving your original content. From here to here, where you have the largest alpha, or to here, where you have the smallest alpha, which results in a totally nonsense image here.
There's a artistic style which actually looks a lot like the actual paintings look like, a lot like the upper left. I'm not like it's an actual art form.
Yeah, should be
without any content.
That's right.
With, but I actually have seen real pictures of things like that.
Yeah.
Yeah, but
okay.
So is enough spatial information transferred in the style? So for example, if you rotate the style image, do the colors follow the stylistic transfer, follow the more of the rotation of the painting, the style painting? Do you guys know what I mean?
You shouldn't, right? Because style has nothing to do with vision.
It shouldn't, but I'm saying whether the mathematical operations still push it to align that way, because you're doing a pixel by pixel transfer, right?
I think it will. I mean, if you rotate it, it won't be the same.
Right, because let's say, look at all of these images in the one except for the top left, all of them, the rightmost house is yellow. But that could be an artifact that the actual original house was yellow too. I'm not really sure about that.
I think it's due to the original color, because you can see the
Yeah.
all these houses are all following the original color scheme provided here.
Right.
Yellow, pink, white.
Are any of you guys working on? I think there was at least one person doing style transfer in one of their projects. Anyone? No? You guys are all doing serious stuff? No artistic stuff? Okay. All right.
Okay. Yeah. So maybe we can get more interaction, so you guys can like provide some of your own understanding. So I posed 2 questions here. It's not difficult. Maybe, yeah, let's say the first one. Because if you refer back to the architecture of the model, you can see for the style images, we are actually using the intermediate result from each convolutional layer. But then for the content transfer, we're only using one of the convolutional layer result. So the first question, like, how does this choice of higher or lower layer affect the final content? The example can be found here. This is a result generated by the convolutional layer 2 for your content, while this one is for the 4th layer. So maybe you guys can share some of your understanding on why these 2 final images look different.
So the higher up the layer is, the easier it is for the network to identify complex images. For example, you'll be able to identify, say, windows better at a higher layer than at the lower layer, where it's better at tackling, say, just edges or more basic geometric figures. So I think that's why when you do with, say, that layer, you're getting an image which closely looks like a window, whereas the other layer it's not.
wait, what's high and what's low?
Low means closer to the image features direct, the raw image features. So the middle one, conv 2, is the lower level features, right? And Conv4 means closer to the fully connected or the top level.
So the closer you are to the original image, the closer your picture will end up being to the original. Like you don't have much freedom of deviating from the original image. Whereas like when you go deeper, you get more freedom. Get far away from the original.
Yeah, actually, one of the points we can actually see from this example is the circle, or the thing looks like a circle here. If you observe the same point for these two following images, we can see in a lower layer, the circle is still a circle, but somehow in the upper layer, it's really a rectangle here already. So I guess one of the points here is comparing the higher layer against the lower layer, then the lower layer is better at preserving the basic shapes, the basic painting strokes, which means some of the detailed shapes you can see from the original picture, like the very small circle or very small rectangle. That's why you see if we use a content from a lower layer, then these small features get preserved very well. Yeah, and yeah, following this question, why in the architecture we only use one layer for content, but we use multiple layers for the style image?
So just to clarify, on this particular slide, Conv2 and Conv4 show that stylistic transfer when restricted only to that.
Yeah, this is the only variant.
But when we typically apply style transfer, we do it at all of the layers. Is that right? Not just at one. You were just saying on the other slide that you have style applied at every layer, and the content only applied at one layer.
Actually, if you want to do, you can also apply to multiple layers of content. But for this particular implementation, they are only using one layer for the content, but multiple layers for the style.
Which application? You say there are several different ways of doing style transfer, but you're talking about a particular one. Which is this one here. This is the generic, the baseline, shall I at least call it, the baseline style transfer.
Actually, this is a baseline provided by the author. And this is another implementation provided by one of the researchers online.
Okay.
Yeah. So the rationale is this, but then there are multiple ways you can alter and combine the MSE from the style and also the content.
Mm-hmm.
Yeah.
Moderators.
Do you guys have any thoughts on why we're only using one layer from content, but then we use multiple layers for style?
I mean, for content, you have different, so each level gives you a different level of abstraction. And if you would use multiple layers of content, you would mix different levels of abstraction of your original content. And I don't see why, like, intuitively, that doesn't lead to any meaning. Like, you mix basically the how squarey is something and how much it looks like a chair, if you actually only want to do one of these things. So I think it doesn't feel like it would have any meaning for you guys.
Yeah, so if we actually follow the same logic, for the style, we are not looking at what is inside the style image, but instead we're looking at how color are arranged inside this image. So we want to, yeah, it's actually falling back to this equation here. We want to see how each row interacts with another row, and intuitively, how each layer, how each feature interact with another feature. Remember, in the original model, we are feeding the original image into a pre-trained image classifier. So each of the layer, the result will tell us something about the filter, how the original image interacts, how they relate to the filter. So it's still the like a different logic for how we value content and style. And also some further remarks that this is not this model is not restricted to the use of image. I can say painting synthesis. You can also apply to existing photographs, because judging from the nature of this model, literally you can put anything here and here. So one of the application you can people are finding in modern camera applications is that you can combine two different photographs together. Say, for example, here they are combining the light effect, I think it's from London, and then combined with the city of New York City. Yeah, and then result in the following photograph. And some of the issues, it's still the same thing, how you value style versus content. First one is the definition of style is already very vague, or I can say ambiguous. How you define a style? Does it mean the painting strokes used by the painter? Does it mean the color scheme? Or does it mean what kind of shapes you are putting inside the image? So the definition of style is already ambiguous. So there's no clear criteria on how you want to add this style into the content. And next thing is, can style and content really be separated? As you guys have put earlier, in this image, you can see the original sky is quite clear, but then after you combine with a starry night, somehow the star show up in the sky. This actually gives us another problem. It looks reasonable in this image because in the same position as a starry night, we have a sky here. So it's perfectly fine if you put a star here. But then if you combine with the image of the bird provided by the video, then it might not look so reasonable or so intuitive, because the original structure of the image are different from Starry Night. But like I said previously, it's because this is image synthesis or is artistic style, it's related to arts, so there's no things like right or wrong, no fixed criteria to judge this. And the author has also mentioned this. There's no way of effectively evaluate whether your model is working fine or not. Yeah. So basically, this is the core architecture on this image style transfer. Later, I think we will talk more about some of the advanced concepts built on top of this model and some of its extensions.
We are going to introduce some measure to control the image, the styles on an image. We know we have a style image and a content image, and we input the image into the algorithm. Then we get the output. Now we want to control the output, the output image. So we will show several examples to introduce 3 different measures. The first one is about the spatial control. Spatial control. We can see there are clouds and the sky in the content image. Then the for the style image, it also has a sky and a house. And for the second one, it also has a sky. So we sometimes we may only want to modify the house style, and we also may only want to use the house style in the style image. So we can see the image the D image. It uses the original image directly. So the result, we can see the result. The sky style is also modified. So we want to avoid the sky. We may only want to change the house style, like the image. Then sometimes we may want to use different style. For example, we want to use the sky style from the second style image, and use the house style from the first style image. So how can we implement this? It is very simple. We can use masks to do this. We can use a mask to partition the image into two different regions, the sky region and the house region. So after use the mask, we see this is the mask. They use this mask to partition the image. So they get the result.
Sorry, can you go back to the masks earlier? You had a slide where you're calculating the masks.
I'm talking about the.
Can you again explain how do you select the regions? I didn't quite catch that.
They didn't talk about how to generate the mask. They only say you use the mask to partition to select different regions.
So it's given to you that you have a mask already?
Yes.
And does anyone describe how you get the mask? Is it just based on normal image or object segmentation? Then masking is pretty common in a lot of programs like Photoshop or other things of that sort, where you for pixel values of similar saturation or color.
And use a neural network for that, right? Mm-hmm. As described in the last week's video, you can basically use a classifier and look where it actually activates. You train a house classifier and then you look which region looks most like a house. Not sure if that's how it's done here.
Right. So we have object detectors, and the object detectors are now able to define the polygon around the exact part of the image, right? So I think Martin, right?
Yeah.
Martin was saying that you could use that as opposed to the generic type of magic wand, if you will, function that you have in photo utilities that look at pixel value. Okay, so it's just given to you that a mask is already pre-calculated for you, right? Is that correct?
Yes.
Okay. And then you apply the appropriate style transfer on that image.
Yes.
I think if you go back to the previous slide, yeah, you see on the top 3 small images, you see this icon here. So I suspect they're using some image.
Right, is that a binary mask in or out, right? They're not even using any type of smoothing, right? It's either a pixel is part or it's not part.
Because it looks very much like Photoshop.
Yeah. But even Photoshop, you allow partial selection, right?
Yeah.
You can say a pixel is 60% in the selection, 40% out, right? Because many objects that you might want to select have shadows or they have edges that are blurry. Okay. Anyways, they're using a hard mask.
I think so. I just posted this article.
Okay.
They describe sort of what they do is they invert the colors of the content. So then, what it leads to is like if you scroll down, you can see first it learns say the shape of the image, but then since the colors get inverted, it just fills in the style into that. So I think that's one way of creating a mask also.
You said they do some inversion to get a silhouette.
Yeah,
Is that
exactly.
right?
Yeah.
Okay.
For each layer in the convolution neural network, the shape of the feature is different. So we also need to modify the shape of mask. We can use a simple way. We can just we can only down sampling the mask to the same shape. But we can see the second row. The house will lead to the sky region. So they recommend to use this one, the first row. Assuming this is a kernel in the max pooling. In the max pooling, we choose the maximum value, but now we choose the minimum value.
So you're min pooling here.
Yeah.
But max pooling on the bottom, right?
Yeah. But if we use max pooling, we will leak more region. So next we are going to talk about the color control. We can see this is the original agreement. The color of the content image is modified. The original one is green, but now it become blue. So they use 2 different ways to do this to avoid the color change. The first one they only do the image style transfer on the luminance channel. And the second one, they firstly they transfer the color from the content image to the style image, then use the new style image to do the image style transfer. So we can get the result.
I don't quite get that. Do you guys follow? You said in the second one, they're just trying to match the color histogram. But what type of style is being transferred here? If you match the color histogram with the original image, then you're just transferring the luminance channel. Is that right? I don't quite understand how the second bullet point here works.
This one.
Yeah.
For each they say that there are many different way to do color transfer. And they use a simple way. They say use a linear measure.
Right, but what does the second version actually mean? Because originally we were thinking that style had a lot to do with color, right? So now you're saying I don't want to match the color. I only want to match maybe the brush stroke or the texture of the image. Is that what it means when you ignore the color histogram of the target image? The color histogram of the style image, right? So for example, here B is very blue, right? And if you just normally do the style transfer, you get something like C, right? That's what I understand.
Yeah.
Right. If you do just the YUV luminance transfer, you end up with D. And if you ignore the color histogram from the style image, ignore the color histogram in B, you get something like E. Is that right? So you're stylizing it to look like the texture, I guess. Is that right? The texture and the relative differences between pixel values in B are being transferred to E. Is that what is being meant by that? What do we mean by style when we ignore the color histogram? Right, because you're replacing the color histogram with the original color histogram, right?
The structure.
Save what?
The structure.
The structure? Okay. Do you guys have any insight into that? What do you think is being transferred?
I don't quite understand like why E is still like so greenish, although like the color histogram is really transferred.
Gray? Why is it gray?
Like green.
Green.
Yeah.
Yeah. So both D and E are ignoring some version of the color in the style image, right, and preserving what is actually in the original image, but transferring only certain aspects of the style. Right, so Ru Wei said that the D one is only using the luminance. So if you don't look at RGB color, but transfer the color into a different representation, YUV, right, then you can transfer only one component of that. It's sort of like the brightness aspect rather than the hue, right? Hue, we usually think about color, right? So we ignore the hue, we ignore the color, but we care about maybe regularities and brightness. That's my best guess, but you guys are welcome to help me correct.
Yeah.
Right?
Following your guess, like D looks like, because the style image is like spotty when it comes to luminescence. It has like spots of being white. And you can kind of see that like there suddenly appear tiny spots in the green, which are a lot brighter than the rest.
Mm-hmm.
So it seems like these spots are transferred.
Right. So you see the little stars in the sky in the mango style image, right? And then it's being transferred into artificial flowers that are somehow a lot brighter in the transfer image. Is that what you're saying?
Yeah.
Yeah. I also think that like the style image has like that glowing quality, more luminance, right? And so they're trying to transfer that in the bottom one, because you can see the whole patch of purple flowers is somehow blurry and more glowy, right? So if you take away the hue and just transfer brightness component, right? That there's some regularity between pixels about the brightness. It doesn't fall off very rapidly. It's not as crisp. So that's being transferred. For E though, I'm trying to understand what is being transferred if the color itself is not being transferred. So you're preserving the RGB color of the original image. Not exactly, right? Because you say you're matching the histogram, only the histogram, not the individual color element. So you're still allowing the color per pixel to vary, but you want to have the color histogram of the entire image be the same as in the content image, right? So if I look at the two histograms of A and E, their color histogram for RGB should look identical or very close, right? So then I'm allowing some variance within neighboring pixels, but the whole image must look more or less the same histogram. Is that correct? So I'm allowing some local variations and local optimizations to match the style of the style image.
They modify the style image first.
Oh, sorry, they modify the style image. So we don't actually get to see the modified style image. That would be interesting. So you're actually doing the transfer to the style image.
Yeah.
You're first modifying the style image to match the color and then using that one to modify. Okay. Two-step style transfer. Okay. So color transfer and then style transfer. Does that make sense? Wouldn't it be better just to isolate the component of style that you want to transfer and just transfer that?
Don't you lose the style if you transfer from the content to the style?
Don't you lose
some aspect of the style that you want to preserve if you transfer the histogram of the content into the style?
Yeah, so I think that's what their goal is. They want to omit some part of the transfer, right? They say, I want to match the color to a certain extent, right? So Eugene, you put another link. What's that one about? And so did Shenhao. Okay, let's go on.
Finally, we want to introduce to mix two different style image to generate a new style image. For example, there are three different style images. Then we merge the first style and the second style to construct the first style image here. Then we mix the second style image and the third image. We get this style image. They use a very simple measure to do this. They use the convolutional neural network directly. Use the image style transfer algorithm directly. The difference thing is they only use the low layer, and the initial set the initial image as the course style image. The course style image is a lot larger than the fine style image. For example, the first style image is larger than the second style image. Then they use the same algorithm to modify the course style image to get a new style. So they use a very simple way to do it. That's all.
Can you go back? So in C, they mix the style with the content, right? I mean, it becomes violet, and the only thing which is violet is the content picture. Like, so what's style 4 and 5? So this looks
They're
like
creating a new style. So probably 4 is combining, the content and the middle one in, style 1, 2, 3B. And style 4 is the new style.
so, but what does it mean then? So style 4 is 1, 2, and content. I
No,
just
no,
want-
no,
I
no,
just
no,
don't
no.
understand
Oh,
the color of style
Style
4.
4 is content
The-
2.
They only mix the style images.
But
Oh,
why
it's a
does it
style
become?
images.
But why does it become the color of the content if you only mention?
Yeah.
Or is
Yeah,
it just
the
accident?
color has to match. The color has to come from the content. There's no other purple, orange from anywhere else.
Oh, I thought you made a new style by using content and style 2 and then putting on another image.
Then I don't really see what. So you maybe I don't get. I mean, what I especially don't get is why combining style 5 with the content should lead to anything else than combining style 3 with the content. Basically,
And I think that they also transfer the color from the content image to the style image.
so they focus on the stroke side. Okay.
Can we find the original paper that discusses this so that we can find it? Because I think Ruwei has already come to the end of his talk, right? Okay. So I think, okay, Shenhao posted the original paper from archive, so why don't we go get that? And we can talk about that. Thank you. So I'll drive for a while. It'll take some time. I think everyone in the room is hitting archive, so we might get a DDoS from NUS. Cease and desist.
And use it.
So it looks like it's on page 6. Here we are. Scale controls the neural style transfer. Content image, collection of styles used. Style 1 has dominant brushed strokes on a fine scale. Style 2 has dominant angular strokes. Style 3 has dominant round shapes. New styles combining coarse and fine grains of existing style. Style 4 combines fine style of 1 with coarse scale of style 2. But they still, both here, don't say anything about the color transfer, right? The color transfer should have come from the content. It couldn't come from anywhere else, right?
They're applying it on the content.
Okay, they're applying it on the content. But if you look at this image, it looks like image 2.
Yeah, exactly.
And this one image looks like style 3, right? So I'm not quite sure about what's going on there, all right? If you do the straightforward style transfer, which is like you take this second with style 2, this second style, and apply it here, you I guess this is A content, yeah, plus 2, right? And this is output with style 4, which is a mixture of which one? 1 and 2, is that right? Did they say that? Style 4 combines 1 with 2, right? So we take 1 and 2, mix them together to get this, and then combine this and this, transferring the content from this image and the style from this image to get this one, right?
How?
But how?
Did they get this style?
How did they get this style?
Yeah.
Yeah, let's see. I don't know. Let's see. Here we show a way that combines styles to avoid this problem. Okay. So it says, we first create a new style image that combines fine scale information from one image with coarse scale information from another. Figure 4C. We then use the new style image in the original neural style transfer. We do this by applying neural style transfer from the fine scale to the coarse scale using only the grand matrix from the lower layers. So when they mean coarse or fine scale, I guess they just mean different levels of the neural network, right? E.g., only a conv 1.1 or a conv 2.1 in figure 4. The resulting images in figure 4C are used as the input to the original to generate a new stylistic stylized of the cityscape photograph. Okay. Yeah, it's still not very clear to me how they got the color off of these into these images.
If you scroll down to 7.2.
7.2, spatial control.
Yeah, scroll a bit more. See, even here they are definitely combining it with the content. Oh, it's not the same.
These are output with style 1 and 2. These are the styles that they're using, right? They're definitely not any blend of the content, right? Because they have their own color, right?
Oh, they didn't create any style.
But see, output of style 1 is content plus style 1.
And this is output of content with style 2, right?
I think the output with style 1 and 2 has. It looks like the. For a second, it looked like the first output had both the styles.
The first output had both the styles. I don't
second,
think so. Yeah, it looks like it's just style 1, which is this one up here, right? It's because that's the color from that. Well, it's very interesting that this style transfer resulted in something very different from this, right? If you look at this image up here, it's actually pretty high res. Yeah, it's still pretty smooth at this point. You don't see any of these bumps and swirls. They're sort of transferred from this part of the image, I guess. The neural network has gotten very fine-grained features for transferring at that. I would have expected her face to be much more smooth, something like on this side, but it's quite knobby. Yeah, you can see the background transfer just fine. It's sort of like in this general sense, but still not quite right. Right, but because of this, I guess there's a lot of small RGB value differences on her face that they decided to do much more fine-grained control. You don't see that much of these small artifacts on the background. I guess because of the bokeh, right? Because it's unfocused and a little bit blurry.
Could it also be that because they use for the style transfer only one of the lower levels, so that they learn only, say, smaller features?
It could have. Let's see. Did they say anything about this down here? Styles Candy and Feather. See outputs from 13 train with styles shown in B. I don't know which paper is 13. Let's see. This is Justin Johnson and Fei Fei Li's work in ECCV. The Stanford group.
I think maybe it's because some of the small corners in the image, which is not so perceivable to us, but then judging from the RGB values, something influential to the network. Because if you see image E, they're actually only transferring the luminance. Somehow you see her hair also got this more bars.
Yeah.
So probably it's because for us we cannot see from the original picture, but then for the computer, for the algorithm, it's actually seeing the variance.
Can't zoom any more than that. That's pretty zoomed already. Yeah, so we do see some artifacts in her hair. Right? And I guess those are being accentuated quite a bit, really. They look pretty ugly to me. I don't know. It reminds me of knotted wood. So there are other, I think, recent works on style transfer about trying to find a take a lot of artwork and reduce it to some elementary styles. I remember that from the Stanford course that we talked about last semester, where you're using just, you know, some parameters to define what a style is, right? So you just say, I have some primitive styles, and then I use some mixture, some W weights to figure out which styles I want to encode into my new style, and then throw that into a network, right? So that's also quite interesting. I don't remember which one that is. So I guess we'll end there. It's already past time, but it would be interesting to think about on Slack or otherwise about what makes the style. Are there things that people haven't covered with respect to style? Style seems to be something quite localized, right? You're not looking for global information here, because when you compute the Gramian matrix, you're basically, as Shenhao said earlier, trying to lose location information and just deal with local perturbations in RGB or YUV color space. Right. Okay, so next week we'll continue with the next lecture. So thanks for coming, and see you next week. Thank you. Thanks for our presenters.